So we are supposed to derive the reduced time equation for the question below, given that theta is equal to t over t 0.5. How do you go about this? So with this video, I'm going to teach you how you can do this and also examine if this data fit any of the kinetic laws. So now we're given three kinetic laws, which is A, 1 minus bracket open 1 minus alpha bracket open exponent 1 over 3 kt. And the second one is 1 minus 2 over 3 alpha minus bracket open 1 minus alpha close it 2 over 3 kt. So what do you do about this? Now with this we need to know that always we need to know the value of alpha, and here this is the value of alpha. So always know that this is the value of alpha, which can be seen from the table, right? So the value of alpha given to us was 0.5. Then with that, it's going to help us to derive the reduced time equation for each of this model. So what you do now is we're going to look at the first one. With the first one, as alpha was 0.5, so now note that the other alpha value can be also selected. So note this, it's not only 0.5 can be selected. Any of the alpha values here can be selected for this. So when you learn how to do this using any of the using 0.5, then you can use any of the alpha value for your calculation. So now let's go for model 1, which is this. So model A was given as this. Now what you do now is that we are trying to derive the equation, right? So from the question here, they say derive the reduced time equation. So we are going to derive this in terms of theta, and theta is t over t alpha, and alpha is now 0.5. So let's take equation 1. When you take equation 1, then we are going to equate the original equation. So so this is the equation given to us. So let's name this equation 1. So this is equation 1. Then we are going to replace the t with t 0.5. So we're going to replace it with t 0.5 because that was the condition given to us. So we have this. Then what we do now is that we're going to solve this simultaneously to get the theta. How do you solve it? So we are going to divide equation 1 over equation 2. So equation 1 over equation 2, this is what you're going to do. Equation 1 over equation 2. So when you do that correctly, but before we do that, let's try to simplify this. Now, alpha was given to us for equation 2 as 0.5. So we are going to do some substitution. We are going to put alpha into the value, right? Then get a value for this. Let me take my calculator and let's see the value we'll get. So I'm taking my calculator. Let's cast your calculator. So when we take the first equation, that is 1 minus, that is bracket open, 1 minus, that is 0.5. Then let's close the bracket, and its exponent, that is 1 over 3. So when you do that correctly, it means that our answer that we will get from the calculator is 0.206. That represents this. So we have 0.206. So let's continue. So then it means that for equation 2, we are going to get 0.206299 is equal to k t 0.5. So we are going to substitute it here because we now reduce it now. We've reduced it to this. Therefore, when we are going to substitute it, when you do that correctly, then I told you are going to divide equation 1 by equation 2. When you do that, it means that equation 1 will have 1 minus bracket open, 1 minus alpha bracket close, exponent 1 over 3, right? So after finding the alpha, putting the alpha value to get 0.206299, then you're going to go on and divide. So you're going to divide equation 1 by equation 2. When we divide, you can see this. Now, the k will cancel the k, right? And we're going to get 1 minus 1 bracket open, 1 minus alpha close, 1 over 3 over 0.020699. What you do now is that we're trying to find theta, right? So when we do it, you're going to get this because we try to multiply this by the whole expression. Now from the question, they gave us that theta is equal to t over t 0.5. Then we can replace this with a theta value. So this is we've derived the reduced time equation for the first model, which is this. So kindly pause the video, then try the second model and and the third model. I know you've tried it. So when you tried it, this is what you get. For model B, using the same procedure, you're going to get 1 minus 2 over 3 alpha minus bracket open 1 minus alpha bracket close exponent 2 over 3, which will give you 0. That's theta times 0.04. And with model 3, you're going to get this. I hope you had it right. Yes. So after, what you do now is that we are done with it. So we are going to use the alpha value to find the theta value, use based on the models that we got. So the first model, we're going to put when alpha is 0.3, then we get a theta value. Second model, when alpha is, so we are going to take first model, put alpha all inside. So on the table, we are going to get this. So for the first model, when you put alpha is equal to 0.03, you're going to get this. When you put this, alpha is 0.40, you're going to get this. As continuous, you're going to get it. So you take first model, then you put alpha inside to get this. Then you take the second model, you put the same alpha inside and get this. The third model, you put the alpha inside and get this. Let me see. Let's use the second model to see what I'm trying to see. So let me take my calculator. Let's use the third model. So for the third model, what I'm trying to tell you is that okay, so let's use the first model rather. So let me go here. So you have this as the first I'm coming. So with let's use the model C. So we have negative ln, that is bracket open 1 minus alpha was here for alpha they've given our alpha to be 0.3, so 0.3. Then we try closing the bracket. I'm trying to solve it using the equation on the calculator. So alpha plus solve, then we're going to equate it as the theta. I'm going to represent the theta with an s, so x here, then times 0.69. Then I press shift plus solve, then I solve for x. So you can see that x for the third value, it's for the first one for x this side, you're going to get 0.151. Approximately, you're going to get 0.152. So when you do continuously using the calculator, you're going to get a value for that. Now, after getting the value, what you do now is you're going to plot a graph. Now, you're going to plot the alpha against each of the theta of the model. So you take the first model, then you take this first model, you're going to plot alpha against this model to get a curve. And you're going to take alpha against the second model to also get a curve. And you take the third model, that's alpha against the third model, you get a curve. So this is the alpha as the y-axis and the x-axis being the theta. Note, theta is t over t 0.5. Now after getting this, then we are trying to find, so with the first question, we had the model to be this and that, and the first one that I proved with you guys. So how do we determine whether each of the data given to us satisfy any of the laws? Then we go to the next one. Now, what we do now is that we're going to take the temperatures, right? Now, they gave us that alpha was 0.5. So from here, alpha was 0.5. What to do now is that we're going to take the first temperature, which is 1000 degrees, then divide by, when you look through, with a 0.5 on the temperature, you know that it falls between this, and that. So what you do now is that we're going to divide, since they gave us that theta is equal to t over t 0.5, you're going to divide by the value of 0.5 with this temperature. So with this temperature, you're going to divide this 0.2 over 0.5, 0.3 over 0.5, 0.5 over 0.5, 1.5 over 0.5, 2.5 over 0.5. So you're going to divide this by 0.5 because with the 0.5 line, this is 0.5. Then you go to the second temperature is 0.7. So you're going to divide all this by 0.7. And the third temperature was 1.5. You're going to divide by all 1.5. So when you do that, you're going to get this table. Let's take my calculator and let me show you what I'm trying to tell you. So with my calculator, that is this calculator. So now what I'm trying to tell you is that when you take the first one for 1000 degrees Celsius, you're going to divide all by 0.5. So when you take 0.2, that's 0.2, you're going to divide it by 0.5, and that will give you 2 over 5, which is 0.4. That's why it has 0.4 here. So that's what I'm trying to do. So you're going to divide all this by the alpha corresponding with the temperature. So 0.5, you're going to divide this by 0.5, divided by 0.7, divide this by what? 1.5. Then what you do now is that you're going to plot each of the temperatures. So what you've got in here, you're going to plot this against the alpha value. You're going to plot this against the alpha value. You're going to plot this against the alpha value. So now when you plot against the alpha value, what you're going to get is this is the graph you're going to get. So for the first model, it's represented by this. So this is the model that asks to draw. So you've drawn your curve already. Then for us to find, for you to find the model from here. So you're going to plot the alpha value against the theta value, which is for the 1,000. This is this. So wherever you see the green is for the 1,000. So 1, 2, 3, 4, 5. You're going to plot it, but with it is scattered plotting. You don't need to join the point. Then after plotting, you check on the model which model has the highest temperature falling on. That's when you plot the alpha and each of the temperatures, which one has the highest point passing on. And if you check, you see the one having a lot of point on it, that represents the kinetic law. That data satisfy that kinetic law, and you can see that that is B, because B has a lot of temperatures falling on it, because it's fall on it. So that shows that that is the kinetic law. Thank you very much for watching this video, and kindly subscribe and like. Thank you.